radiation sheets are used to reduce the heat transfer by effectively increasing the surface resistance. That's what we discussed in the previous class. The arrangement looks like this. So there are two plates, 1 and 2, and you can add a shield here. You can add number of shields, more than one. We are taking the simplest case of one shield and then draw electrical network analogy. Right? So total of 6 resistances are there. So the heat transfer rate is equal to overall potential difference in the two extreme nodes divided by sum of all the resistances. Have you all noted it down? Right? So this is the formula for this diagram. Now, this is the formula applicable for any geometry. The radiation sheet inserted between any two geometries. Now for the specific case of large parallel planes, large parallel planes, and shield also of the same size, as large as both of these plates, right? Very large parallel with the distance between them very small compared to their original size. So for such cases, the area of both the plates or planes and the shield, S is used for shield, all are same, right? And what happens to the shape factor between 1 and S or between 2 and S, or S and 2, right? Because we are going in one direction from left to right. So S to 2 is also equal to, in the absence of shield, 1 to 2. So this is all equal to 1. So substituting this in this equation, what we get, Q1 to 2 is equal to EB1 minus EB2 divided by 1 minus equal, let us say A, simply 1 minus epsilon 1 by epsilon 1 into A plus 1 by A into F1s is 1 plus 1 minus epsilon S by epsilon S into AS is also A plus 1 by, again, 1 minus, it is 2 times, minus epsilon S by epsilon S into A plus shape resistance between shield and second plate, 1 by A into 1 plus 1 minus epsilon 2 by epsilon 2 into A. So EB1 minus EB2 divided by A being common in all the terms, let's take it out. Now 1 minus epsilon by epsilon 1 by epsilon 1. So this is 1 by epsilon 1 minus epsilon 1 by epsilon 1 is 1 plus 1 by A is already taken out, now it will be 1 plus 1 by epsilon S minus epsilon S by epsilon S plus 1 by epsilon S minus epsilon S by epsilon S plus 1 by A is already taken out plus 1 by epsilon 2 minus 1. So this is the simplification for special case, right, of large parallel plates. Now, this minus 1 plus 1 gets cancelled. Minus 1 plus 1 gets cancelled. Now you see, you are left with, you can take this A to the numerator, then Q1 to 2 is equal to A into EB1 minus EB2 divided by 1 by epsilon 1 plus 1 by epsilon s minus 1 plus one more time epsilon s plus 1 by epsilon 2 minus 1. Now the numerator EB is sigma into T1 power 4. So sigma T1 power 4 minus T2 to the power 4. So sigma into A into T1 to the power 4 minus T2 to the power 4 is numerator. Now I am rearranging this as 1 by epsilon 1 plus 1 by epsilon 2, right? Minus 2 into 1 by epsilon s minus 1 plus 1 Q1 to 2, right? So this is the equation for the given case where there are large parallel plates. You may use some equation number at least to use this, right? Is there any other equation preceding this under radiation sheets? It's not there, right? So this is the equation. So this, anyway, there is no change in the numerator, right? It's the overall potential differential we take. The between the extreme nodes. Now in the denominator, epsilon 1 represents the surface resistance of 1, plate 1. This is that of plate 2. Each one time only. 1 by epsilon 1, 1 by epsilon. But here there are 2 times. This resistance of surface resistance of sheet is coming twice. Why? Each one of these 2 plates, 1 and 2, is pumping in only one resistance, right? Here there are 2 resistance of the shield. Why? What's the reason? Shield is exchanging radiation on both sides, whereas the plates are exchanging radiation energy only one side. Right side of plate 1 and left side of plate 2. So that's why it's a 2 times. Right. Now, earlier in the absence of shield it was just minus 1. For 2 large parallel plates, numerator remains the same. In the denominator 1 by epsilon 1 plus 1 by epsilon 2 minus 1. Right. So what that 1 represents in the earlier case, space resistance. Right. Obviously there should be 1 space resistance and 2 surface resistances. 1 by epsilon 1 is surface resistance 1, right? 1 by epsilon 2 is that of 2. And in between how many spaces are there? There is only one single space between 1 and 2 in the absence of shield. So therefore there was one single one. Now there are 2 ones. One is repeated twice. Why? How many spaces are there in this structure? There are 2 spaces. One space between 1 and this shield, another space between the shield and 2. So therefore you are getting 1 plus 1. Suppose if there are n number of shields, if there are n number of shields placed between surface 1 and surface 2. Then how should you write this equation? See, observe here carefully. Q122 is equal to sigma A T1 to the power of 4 minus T2 to the power of 4. Right, will be there. Divided by 1 by epsilon 1 plus 1 by epsilon 2 minus 2 into, right? See here, 1 by shield 1, say S1, 1 by shield 2, epsilon 1 by and so on up to n number of times, right? You would have that minus, when n seals are placed, how many shape resistances will come? N plus 1 minus n plus 1. So now this can be written as sigma A T1 to the power of 4 minus T2 to the power of 4 divided by 1 by epsilon 1 plus 1 by epsilon 2 minus 2 into, we can write this as sigma I is equal to 1 to n 1 by epsilon s. Read okay? Can you write like this? Right. Minus of n plus 1. So this is for any number of sheets. That is only for one sheet. So this is an extension of that.
Sir,
Yes.
any equation placed separate one place epsilon 2
Where?
equation one is
Sorry.
place 2.
Sorry. Plus. Resistance should be increased here. Only when resistance is increased, the heat transfer will increase. Plus. We write note. Since the sheet neither adds or removes, heat from the overall system, it can be considered to be in a state of thermal equilibrium. Which means that when can it be? See, the very fundamental nature of the steel is it will not add any heat, nor it will give the heat to the system. It only stops. Imagine water is flowing and you have laid some obstruction, right? It is neither absorbing the water nor giving any water to the system. It is simply changing the direction of the water. Its role is limited to that. As simple as that. So now when is it possible? When can that be in thermal equilibrium? Only when the heat transfer on either side is equal. See, it is exchanging heat on the left side as well as right side. So only when these two quantities are equal, it can be in thermal equilibrium. Is it clear? So what does it mean? Q from 1 to S must be equal to Q from S to 2. Right? So which means that how do you write Q1 to S? sigma A T1 to the power of 4 minus Ts to the power of 4 divided by 1 by epsilon 1 plus 1 by epsilon s minus 1. Surface resistance of plate 1, surface resistance of shield on left side, and one space resistance between them is equal to this one, sigma A chapati into Ts to the power of 4, T2 to the power of 4 divided by 1 by epsilon s plus epsilon 2 minus 1. So using this equation you can find the temperature of the shield if you know the temperatures of the plates, right? Please note down.